Hello everyone, you have joined with the discussion of the GMSA Physics MCQ for the year 2025. So let's begin with the first question. In the first question, they have given you this equation, and the question is, if eta equals coefficient of viscosity, r equals radius, p equals pressure, u equals initial velocity in the given expression, the dimensions of k1 and k2 are. So first what you can do is, you can multiply 2k1 with the physical quantities they have given inside the brackets. Then using this expression and using the dimensions of coefficient of viscosity, you can find out k1. So then once you simplify this, you can see that the dimensions of k1 is equal to LT. Then using the second expression, and since you know the dimensions of k1, you can find the dimensions of k2. So the answer is m L minus 1 T minus 3. So the correct answer in this MCQ is the second answer. So then let's move on to the second question. In the second question, they have given you a figure and they have given you this question. As shown in the figure, a non-uniform rod has been placed on the container. Find the center of gravity of this. So then let's draw the figure first. So then what you have to first realize is that the rod is in stable equilibrium, and also that the weight passes through the center of gravity. So in sense, since this is a non-uniform rod, the weight doesn't have to pass through the center of the rod. So once you draw two vectors, the normal vectors of the normal reactions perpendicular to the rod, you will get the center of gravity. Using these two vectors, you can find that the weight passes through the point B. Therefore, the center of gravity is at B. Then the correct answer is the second answer. In the third question, a student tries to measure the depth of a hollow cylinder using a Vernier caliper. Reading when the external jaws were in contact is represented in A, while the reading related to the depth measurement is shown in B. What is the depth of the hollow cavity of the cylinder? So what you have to remember is that when measuring the hollow cavity, you don't have to consider the zeroth error. But then you can use this first figure to find the least count of the Vernier caliper. You can see that 0.9 centimeters have been divided into 10 divisions, and then you can get the least count as 0.1 millimeter or 0.01 centimeters. So using this, then you can look at the second figure, and in the second figure you can see that the sixth division of the Vernier scale coincides, and since you are measuring the depth, once again you don't have to consider the zeroth error. The last main scale division is 8.9 centimeters. So with that, you can add the sixth division. So the correct answer is 8.96 centimeters, the fifth answer. In the fourth question, they have given you a statement question. Consider the following statements about a proton. A, it is made up of 3 quarks. Yes, this is a correct statement. It is made up of 2 up quarks and 1 down quark. B, proton is a type of fermion. This is also a correct statement. C, its quark composition is UDD. This is actually wrong. The composition should be UUD, since this is made up of 2 up quarks and 1 down quark. So then the correct statements are A and B. The correct answer is the second answer. In the fifth question, A and B are two-dimensionally identical and accurate liquid glass thermometers. However, the liquids in them are not the same. When bulbs of A and B are separately dipped into identical liquid samples, the reading shown by A is slightly greater than the reading shown by B. Consider the following statements. Thermal capacity of the liquid in B can be greater than that of A. B, both the samples are small ones. C, expansivity of liquid A can be relatively greater. They are asking the true statements. So when we consider the first statement, statement A, thermal capacity of liquid in B can be greater than that of A. So this is correct. What you have to remember is that these two thermometers are dimensionally identical and both of them are accurate. So since they are dimensionally accurate and the reading shown by A is slightly greater, what you can assume is that the thermal capacity of B is slightly greater than A. Therefore, B has absorbed a larger amount of heat energy than A, and therefore the heat energy that is used for the expansion of B has decreased. Therefore, the reading of B is slightly lower than A. When it comes to statement B, both the samples are small ones. This is also an accurate assumption because as the sample gets larger, the error that occurs due to the difference in thermal capacity becomes more negligible. So if there is an error due to the thermal capacity, that is due to the sample being small. Statement C, expansivity of liquid A can be relatively greater. This is actually false. Since the two thermometers are dimensionally identical and accurate, the scales can be adjusted according to their expansivity, and it has been adjusted during their manufacture. So due to that, A being more expansive than B is not a reason for the reading to be slightly greater than B. You should always remember that A and B are two dimensionally identical and accurate liquid glass thermometers. That is, those two are very important points when considering these statements. So then the correct statements are A and B, and the correct answer is the second answer. In the sixth question, they have given you a logic gate network, and the question is, in the logic gate network shown in the diagram, A and B are input while C is the output. Which logic gates should be present at K, L, M in order to get the outputs at C as shown in the table? So in this question, you have to realize that they have mixed up the order, and for this question, you have to use the answers one by one and see whether you get the output given in the table. So let's consider the first answer. So then the first answer says that K should be a NOR gate, L should be an AND gate, and M should be an AND gate. So let's consider the inputs they have given for A and B one by one. So then in the first row, the inputs are 0 and 0. So when the inputs are both 0, the output at K would be 1. At M, it would be, once again it would be 1. And then at L, it will be 1. So for the first row, the output is correct. Then moving on to the second row, the output at B, the input at B is 1. Then the output at K would be 0. And the output at M would be once again 1, and then the output at L would be 0, since there is an AND gate at gate L. Then coming to the third row, the inputs are 1 and 0. Then the output at K would be 0 and the output at M would be 1. And then once again, the output at L will be 0. So then the third output given in the third row is also correct. Coming to the fourth column, they have given both inputs as 1. When both the inputs are 1, the output at K will be 0 and the output at M will be 0 as well. Once both the inputs at L is 0, the output will also be 0. So then the first answer is the correct answer. In the seventh question, a heavy string has been hung vertically as shown in the figure. Here find the ratio between the velocity at the points in the transverse waves along x and y. Consider the cross-sectional area of the string to be A and density to be rho. So here you have to use the equation for the transverse wave velocity. The equation is V equal the square root of T over M. So then T here indicates tension in the string and M is the linear density. So then when considering Vx and Vy, x is the length, so in this diagram, what you can do is you can first find the tension. You can first find a substitute for tension T1 and T2. When it comes to Vx equals T1 over M. So then the linear density of this heavy string is equal at all points. So then M is a constant in both the expressions. Vy equals square root of T2 over M. First, when considering Vx, so the tension here is equal to the weight that is below this point. So the weight below this point can be found out using the symbols they have given for the density and then multiply it by the volume. So then multiply it by the volume. So then T1 is equal to x A and rho. So in XA, as you can see, is the volume below the point T1 and then rho is the density. This is the total tension T1 and then T2 is equal to Y A rho. You can substitute these values into these two expressions. Vx equals x A rho over M. Vy equals Y A rho over M. So they have asked the ratio of Vx and Vy. Once you divide these two expressions, you will get the answer as x over y. So then the correct answer is the third answer. In the eighth question, they have given you this graph and the question is the pressure volume curve of a given mass of gas at temperatures T1 and T2. T is the absolute temperature. Incorrect statement regarding the given graph is. So then in the first statement, they say that T1 temperature is twice the T2 temperature. So when you consider point B and point A, you can apply the combined gas law to the gas at T1 and T2 separately. As you can see, these T1, PV over T1 is a constant, and PV over T2 is also a constant. So when you substitute the values of PV from the two graphs, in the first expression, it's 2 into 10 to the power 5 multiplied by 1 into 10 to the power minus 3 divided by T1 equal K. In the second expression, it's 1 into 10 to the power 5 multiplied by 1 into 10 to the power minus 3 divided by T2. So as you can see, in the first expression, the product of PV is twice the product of PV in the second expression. Therefore, the temperature in the first expression should be twice that of the temperature in the second expression. Therefore, the first statement is correct. In the second statement, at every point of the graph, PV over T remains as a constant. This is true as the mass is constant. This is a constant as well. PV over T is a constant. In the third expression, when gas expands from B to C, as shown in the graph, an energy transmission from surrounding environment to the gas doesn't occur. So in this statement, you have to remember the equation delta Q equals delta U plus delta W. So this is the this is the work done, and work done is equal to pressure into change in volume. So when the gas expands from B to C, there is a change in volume and in pressure. Due to this, there is a work done. So in the work done, there is a work done, and then as you can see, when it expands from B to C, the temperature is constant, and therefore the internal energy of the gas doesn't change. So then delta U is a constant. So if there is a work done here, and then delta U is a constant, delta Q should also have a value. So then delta Q has a value, and therefore there is an energy transmission from the surrounding environment to the gas. And therefore the third statement is false. The correct answer is the third statement. Let's look at the fourth and fifth statements as well. A work is not done by the gas when the gas changes from A to B along AB vertical line. As you can see, the gas changes from A to B, and therefore the volume does not change. Only the pressure changes as well as the temperature. Since the volume does not change, the work done is 0. And this statement is correct. Work done to horizontally take the gas from A to C. A to state C is 100 joules. So in A to C, what you can do is you can calculate the work done. In the fifth statement, the work done can be calculated using pressure into delta V. So the pressure is 1 into 10 to the power 5, and then the change in volume is 1 into 10 to the power minus 3. The answer is 100 joules. This is also correct. In the ninth question, statement A. S waves can travel through liquid medium. This is false. S waves can only travel through solids. In statement B, P waves reach the seismic observatory first. This is correct. P waves are the fastest, and they are faster than S waves, so they reach the seismic observatory first. And in statement C, Rayleigh waves contribute mostly for the motion occurred during an earthquake. This is also correct. So in B and C are correct statements. The answer is the fourth answer, B and C only. In question number 10, due to the equal currents I carried by the below two conducting loops, the change in electric flux, this should actually be magnetic flux, along x dash is correctly shown in the graph as. So first let us draw the two loops. X. So they have given this right side as positive. So then what you have to do is you have to apply the right hand grip rule in this question, and then you can find the graph. So then once you draw the graphs parallel to the loops, so what you can first do is apply the right hand grip rule to the first loop, and then as you can see, the force is towards the negative side, towards the left side, which is the negative side, and as it gets closer to the loop, the magnetic flux increases. The magnitude of the magnetic flux increases. Then as it gets to the loop, it has reached its maximum value, and since the current flowing through both these loops are equal, the magnetic flux created by the loops are also equal. And then when it comes to this side, there's a magnetic flux created by the second loop as well, and it is to the opposite direction, and the magnetic flux created by the first loop is towards the left side. So then it gradually starts decreasing, and then at the midpoint it reaches 0. Then thereafter, as it gets closer to the second loop, and since the magnetic flux is towards the right side, it slowly starts turning more positive, and the magnitude also starts increasing. Then once it passes the second loop, it once again decreases as the distance between the loop increases. So then as you can see, the first answer is the correct answer. Moving on to the 11th question. Lens A is a convex lens with a focal length FA equal 10 centimeters. It is placed in contact with lens B, a concave lens where optical power is 2.5 diopters. What is the focal length of the combination of lenses A and B? So then the power of the concave lens is 2.5 diopters, and the focal length of the convex lens is 10 centimeters. So then using this, you can find the focal length of the combination of lenses. Using the power of the concave lens, you can find the focal length of the concave lens, and as you know, the power is the reciprocal of the focal length. Since this is given in meters, you can convert this into centimeters by multiplying this by 100, and then the focal length is equal to 40 centimeters. Since this is a concave lens, the sign on the focal length is positive. The sign on the focal length of the convex lens is negative. And then using this equation, you can find the focal length of the combination. So then the focal length is F equals minus 40 over 3. So then the correct answer is the fourth answer. In the 12th question, which of the following statements is always true? If an object floating in a liquid is in stable equilibrium, its center of buoyancy lies below its center of gravity. So in this statement, what you have to realize is that they are asking about what are the statements that are always true. So then if an object is floating, the center of buoyancy lies below its center of gravity only if it is partially submerged. And if it is fully submerged, the center of buoyancy is the center of gravity. So then the first statement is false. Under the action of three non-parallel forces, when the object is in equilibrium, the lines of action of those forces meet at a single point. This is actually a correct statement. An object of uniform density, when immersed in a fluid of equal density, reaches neutral equilibrium. In the 12th question, which of the following statements is always true? If an object floating in a liquid is in stable equilibrium, its center of buoyancy lies below its center of gravity. This is correct. Statement B. Under the action of three non-parallel forces, when the object is in equilibrium, the lines of action of those forces meet at a single point. This is actually wrong. They do not have to meet at a single point. An object of uniform density, when immersed in a fluid of equal density, reaches neutral equilibrium. This is also incorrect. The correct answer is the first one. The only correct statement is statement A. In the 13th question, a radioactive substance has a half-life of 3.6 days. Initially, there were 20 milligram samples of it. After 36 days, the amount remaining. So, to do this question, you have to find out how many half-lives have passed when by the 36th day. So, to find that, we can divide 36 by 3.6, and then once you divide it, you get you're finding the n value, and then you get the n value as 10. So once you divide 20 milligrams by 2 to the power n, you can get the remaining amount. 20 divided by 2 to the power 10, and 2 to the power 10 is 1024. Then you will get the answer as 0.019 milligrams. The fourth answer. In the 14th question, a cell with an electromotive force of 1.5 volts is connected in series to a variable resistor R and an ammeter. The ammeter has an internal resistance of 0.5 ohms. Several ammeter readings are recorded as R is varied and plotted against R. If the gradient of this graph, this should actually be y-intercept. If the y-intercept of this graph is 0.88 per amperes, then the internal resistance of the cell is. So they are asking us the internal resistance. So then what they have said is they have first drawn a graph by varying R, and the graph is R, it is against R. So they have given the y-intercept as 0.88 per amperes. So using this unit, you can see that it is per amperes instead of amperes. So you can assume you have to deduct that the y-axis is actually 1 over I, and therefore the unit will be per amperes. So then as a result, once you draw the graph, the y-intercept is 0.88. So then at the y-intercept, the resistance of the variable resistor is 0. Then you can apply V equal IR to the whole circuit. Once you apply that, V is equal to 1.5 volts. And then I is actually equal to, since 1 over I is equal to 0.88, I is equal to 1 over 0.88. 1 over 0.88. Then the resistance, since the variable resistance of the resistor is 0, the only resistors that are present in this circuit is the internal resistance of the cell, which is what we are trying to find. I'll use a simple R. And then R dash, the internal resistance of the ammeter, which is 0.5 ohms. So then we can add those resistances together to get the equivalent resistor of the whole circuit, R plus 0.5 Then you can multiply 1.5 by 0.88, which is 1.32. And it is equal to R plus 0.5. Then the internal resistance of the cell is 0.82. The correct answer is the second answer. In question number 15, which of the following statements are correct? In a PN junction, the positive potential of the internal barrier is located on the N-type semiconductor. This is actually true since the electrons from the N side diffuse to the P side, leaving behind positively charged donor ions on this side. So this side becomes positively charged, and this is a correct statement. In statement B, in a forward bias PN junction, minority carriers also significantly contribute to the current. This is actually false. The majority carriers are the ones that significantly contribute to the current. In C, for diode, the breakdown voltage increases by 1 volt for every 10 degrees rise in temperature. So in statement A is correct, B is false. Then C is also correct. It has been given in the resource book. In the depletion region of an intrinsic semiconductor, the concentrations of free electrons and holes remain the same at all temperatures. This is actually correct since the number of free electrons and the holes are directly proportional to each other. The concentrations are also remaining the same whenever we change the temperature. So then the correct answers are A, C and D. The correct answer is the first answer. So in the 16th question, they are asking the radius of A and B strings made up of different materials are R and 2R respectively. Initial lengths of two strings are LA and LB respectively. The elastic force strain graphs of two strings are given below. This should actually be corrected to stress strain graphs. The graph they have given is a stress strain graph. So this should be, the y-axis should be a stress and this should be strain. Okay. If the extensions are, when forces FA and FB are acting on the two strings respectively, if the extensions are equal, then select the correct statement. So then using this graph, you can find the Young's modulus of both the strings. So then we'll find the Young's modulus of A. YA is equal to, so then as you know, stress is equal to, Young's modulus is equal to stress over strain. And using the gradient of this graph, we can find the Young's modulus. So then Young's modulus is equal to the gradient of this graph. And then the gradient is tan 60. For YA, the gradient is tan 60. And tan 60 is equal to root 3. Then for YB, the gradient is tan 30. And then tan 30 is equal to 1 over root 3. Right. Now using these Young's modulus, we can substitute them into the two equations that we write for string A and string B. For A, when FA is acting on it. Now you have to note that the radius of B is twice the radius of A. Therefore, the cross-sectional area of B is 4 times the cross-sectional area of A. When you substituting the symbols into these equations, FA over A equals, instead of YA we can write root 3, and then the strain, the extension on both these strings is equal, so delta E and LA. Then for B, FB equals 4A equal 1 over root 3 delta E over LB. Now once you equate these extensions, you can get the expression they have given, you can get the correct expression for the forces and the original lengths. So then once you equate these, FA over FA over root 3A equals FB root 3 over 4A. So you get the answer as 4FA equals 3FB. Then the correct answer is the third answer. Then in the 17th question, three tuning forks with unknown frequencies are given as A, B and C. Experiments and their observations conducted by a student with these tuning forks are given below. So then N is the beat frequency. They are given two scenarios. In the first scenario, when tuning fork B is rasped, N between A and B decreases. So what happens is in the first scenario, they are rasping tuning fork B. So when that happens, the length of the prongs decreases, and as a result, the frequency of B increases. Then in the second scenario, they have added wax onto C. When wax is added, the frequency decreases. So in the first scenario, when the frequency of B increases, N between A and B decreases. So then if you write the expressions FA, FB and FC. So then the beat frequency between A and B decreases when the frequency of B increases. So that means that A is greater than B. In the second scenario, when the frequency of C decreases, the beat frequency between B and C increases. Therefore, that means that C is actually less than B. When the frequency of C decreases, the beat frequency between FB and FC increases. Therefore, frequency of C is actually less than the frequency of B. Therefore, the correct relationship between the initial frequencies of the tuning forks are, so then FA is the biggest, and then FB and FC. The correct answer is the first one. In the 18th question, a man stands on a disc that can rotate freely around a vertical axis through its center. The disc rotates under constant torque. Now the person moves from the outage towards the center with constant velocity. Select the correct graph which shows the variation between angular velocity of man with time. So then in this question, they mention that the disc is rotating under constant torque even while the man is moving from the outage towards the center with constant velocity. Since the man is moving towards the center with constant velocity, it does not affect the angular velocity of the disc, since the two vectors are perpendicular to each other. Now once again, the disc is rotating under constant torque. Now we know that tau is equal to I alpha, and as the man is moving towards the center, I decreases. The moment of inertia of the system decreases, and as a result, alpha should increase. Now when we plot a angular velocity time graph, the gradient is given, alpha is given by the gradient. So as the man moves from the edge to the center, the angular acceleration increases, and as the angular acceleration increases, there is the gradient of this graph should also increase. So then the correct graph is graph of this shape. So then the correct answer is the third answer. In the 19th question, plates of a capacitor with capacitance C and charge Q are pulled to opposite directions by some distance. Work done when pulling the plates is plus W. Find the difference of the new capacitance of the capacitor. There is a correction here. It should actually be find the reciprocal of the new capacitance of the capacitor. The plates of a capacitor has a capacitance C and a charge Q. So then the energy here is E equals half VQ. We know that Q is equal to CV. Therefore, E is equal to half Q squared over C. Now, knowing this is the initial energy, and then when they are pulled to opposite directions, the work is done. So then the final energy is equal to this energy plus the work done. So then final energy. Now since the charge is constant, the capacitance is what changes, and then the new capacitance, we can consider the new capacitance as C dash and then write an equation for the final energy, half Q squared C dash. So then half Q squared over C plus W is equal to half Q squared C dash. Since they are asking the reciprocal of the capacitance of the new capacitor, we have to move the rest of the terms to the other side. So when moving them, 2 over Q squared multiplied by half Q squared over C plus W equal 1 over C dash. Now 1 over C dash is equal to 1 over C plus 2W over Q squared. Then the final answer is the fourth one. The fourth answer is the correct answer. In question number 20, so then in the 20th question, in the figure, an inclined capillary tube is shown with soap solution at the top and mercury column at the bottom. Which graph shows how the pressure changes along the axis from P to Q? So then when you move along the line PQ, you can see that the pressure varies, and as you move from P to this contact surface, the pressure is constant as it is atmospheric pressure. And then once you pass this contact point, you can see that the curvature here is pointed towards the interior of the column. Therefore, the pressure on the exterior is greater than the pressure on this side. Therefore, the pressure should slightly decrease. And as you move along the column of soap solution, as you go lower down the column of soap solution, due to the liquid pressure, the pressure once again gradually increases. And as you pass the lowest point of the soap solution, the pressure on this side is lower than the pressure on this side. Therefore, once you pass this contact surface, the pressure should once again increase. And it remains constant as you pass through the air between the soap solution and the mercury column. And you can see that there is no pressure difference between this side and this side, since the contact interface is a straight line. Then gradually, once inside the mercury column, the pressure should increase, but the gradient of the increment is greater than within the soap solution, because the density of the mercury column is greater than the density of the soap solution. So the increment is higher. Then as you exit the mercury column, you can see that the pressure inside the mercury column is greater than the atmospheric pressure. Then the pressure decreases suddenly, and it will be equal to the atmospheric pressure at P. So then the correct answer is the second answer. In question number 21, train A moves with the speed 20 meters per second towards the train B, which is at rest. Sound frequency of the whistle of train A is F1. When train B also starts to move towards train A, so here they have not given that train B is moving towards train A at a velocity of 10 meters per second. That should be mentioned there. Its sound frequency changed as F2. If F2 minus F1 is 10 Hz, F1 and F2 frequencies respectively are. So in here, in the first instance, train A is moving towards train B with a velocity of 20 meters per second. Then train B is moving towards, then in the second instance, here in the first instance, train B is moving at 0 meters per second. In the second instance, train B starts to move at 10 meters per second. Then using these two instances, we can write two expressions for F1 and F2. For F1, the real frequency is 320 Hertz. For F2, so then using the difference between F1 and F2, we can substitute that value into the difference between these two expressions and find the value of V. So then we don't know the sound velocity, which is V. So then F2 minus F1 equals 10 Hertz. F2 minus F1 is equal to this is equal to 10 Hertz. And using this equation, you can find V. You can see that these two terms cancel out each other. Then it's equal to 10 equal V equals 320 plus 20. V is equal to 340. Since then substituting the value of V into these two expressions, we can find the velocity. We can find the frequencies F1 and F2. So then the correct answer is the third answer. In a game which is organized by a group of students, to win the game, a ball should be hit with a target at 4 meters above the ground with 15 meters per second minimum velocity. If the ball is projected by standing on a board which is 0.25 meters above the ground level, what should be the horizontal angle and minimum velocity of projection to win the game? In the 25th question, find the charge of the capacitor shown in the following circuit. So in this question, the current cannot pass through this circuit, but then the current, since the potential, since the electromotive forces of the three cells are different, current can pass through this circuit, these loops. So then the current, an equal current passes through both these loops, I, and then here is 2I, which gets divided into I. Then once again here it's 2I. So then using Kirchhoff's law, we can find the current that passes through this circuit. When we apply Kirchhoff's law to one loop, we get it as 20 minus 10 equal 1I plus 2I times 2. This is equal to 10 equals 5I. So then you get the answer for I and find the potential difference between these 2 points using the value we got for the current. So then as you move along these 2 points, there is a increase in the potential as well as a decrease. So then the potential is equal to 20 minus 4 times 8. Then the potential across those 2 points is 12 volts. Then using the expression Q equals CV, we can get the charge of the capacitor. They have given the capacitance as 2 microfarads. Then the charge is 24 microcoulombs. The answer is the fourth answer. In the 26th question, if sound intensity level of X, who is at 20 meters from a sound source of power 4 watts, is Bx, if sound intensity of sound intensity level of Y, who is 40 meters from a sound source of 20 watts, is By. And sound intensity level of M, who is 60 meters from a sound source of 40 watts, is Bm. So first we can get an expression for the intensity, sound intensities at each of these points. So then for X it is for Y So once you use these expressions and substitute them into the equation that we use to find the sound intensity level, Bx is equal to Bx is equal to you can simplify these expressions. So then Bx is equal to 10 log 10. So then using these expressions, we can find out which of these sound intensity levels are the highest and which is the lowest. So then out of these, you can see that all the other terms are equal, and then the lowest term should be By. So then highest term should be By, highest term should be By, while the lowest term is Bx. So then By is the highest term, and Bx is the lowest, while Bm is the median. So then the correct answer is the fifth answer. In question number 27, a conductor loop with a current flowing through it I naught has a length x and a breadth y is hanged symmetrically as it rotates freely. Now a magnetic field of flux density beta is applied parallel to the conducting loop. What is the angular acceleration that the loop starts to rotate? Moment of inertia of the loop is I. So then we know that tau equals I alpha. So then we can find the tau, which is equal to Bi naught x y. So first we can find out that the magnetic force is equal to Bi L, F equals Bil. So here L is equal to x, so then F is equal to Bi naught x. Then the tau is equal to Bi naught xy. So then substituting that to this equation, Bi naught xy equals I over alpha. Alpha is equal to Bi naught xy over I. So then the correct answer is the fifth answer. In the 28th question, an object is projected vertically from the surface of the Earth with a velocity that is half of the escape velocity of Earth. What is the maximum height that from Earth's surface is reached by the object? So in here, the velocity of the object, so we know that the escape velocity is equal to square root of 2 gm over r. And then escape velocity. So then the velocity which this object is projected is half root gm over r. Then the kinetic energy of this object is Here I'll take the radius as capital R. So then once you now you have to apply the law of conservation of energy. So you can add the kinetic energies and the potential energy of the object, the initial kinetic and potential energy. So then the initial potential energy, since this is at the surface of the earth, is minus GMM over R plus then here the final potential energy and the kinetic energy should be written on the other side. There's no kinetic energy in the final moment, and then the potential energy is, so we don't know the height to which it goes up, so we are going to take the unknown variable as x. So you can cut off the GMM in all these expressions. Then here you get it as minus 1 over R plus 1 over 4R equals minus 1 over x. So then here, once you multiply this, you get the answer as so then x is equal to 4R over 3. So now x is the distance from the center of the earth to the height of this object. Now they are asking the height, maximum height from the earth's surface. So then we have to subtract R from this. So then the height from earth's object is equal to 4R over 3 minus R. This is equal to R over 3. So then the answer is the third answer. The 29th question, consider a situation where a solid conducting sphere is brought into a uniform electric field. Find the incorrect statement from the following. The first statement, charge is distributed non-uniformly within the conductor as the conductor is placed inside the electric field. Due to the induction that occurs while placing the conductor inside the electric field, the charge is distributed non-uniformly. So this is the correct statement. In the second statement, a pure charge is not gained by the conductor as the conductor is placed inside the electric field. This is also correct. It only gains an induced charge. In the third statement, conductor will not gain an electric field as soon as it is placed in the electric field. This is actually incorrect. It will gain an electric field once it is placed inside the electric field. In the fourth statement, conductor slightly gets heated as it is placed in the electric field. This is also correct. Since a current is generated within the sphere, a heat is also produced. In the fifth statement, along the surface of the conductor, a net flux doesn't occur. This is actually correct. So then the correct answer is the third statement. In the 30th question, a metal sphere of radius r gets time t to reach the temperature theta 2 from temperature theta 1. What is the time taken by a sphere with radius 3r to reach the temperature theta 2 from temperature theta 1? Theta 1 is greater than theta 2. Consider that both the spheres have same surface nature and are cooling under the same cooling conditions. So in here we can use two equations for this. So we know that delta q over t equals mc delta theta over t. Then we also know that delta theta over t is also equal to So in this question we can use this expression, and then we can also use the expression where delta Q over T is equal to Ka theta minus theta r divided by theta minus theta r. So we can use this expression instead of this, and then MC delta theta equals Ka theta minus theta r. In both these situations, theta minus theta r is a constant, since both the temperatures in both instances are the same, and then C is also a constant, and delta theta over T is also a constant. So then what K is also a constant. So then what changes is M. M, as we know, is equal to volume multiplied by density, and then volume is, so then M is directly proportional to the third power of R. So then you can see that R, C delta theta directly proportional to K A. So we know that area is proportional to R squared. We can see that Ka theta minus theta r T is directly proportional to R. So then when radius is 3 times, T will also be 3 times. So then the correct answer is the fourth answer. In question number 31, select the correct answer showing the variation of electric field strength and electric potential with distance r around an isolated negatively charged non-conducting dense sphere. So then inside a non-conducting dense sphere, there are charges within the sphere. This is negatively charged. So once we consider the electric potential with distance, so the electric potential is negative at the center, and then it gradually becomes less negative, and then moves towards infinity, moves towards 0 as the radius, as the distance from the sphere gets higher. So then when looking at the electric field strength from the center, this is the electric potential graph. So then when looking at the electric field strength, at the center the strength of the electric field is 0, and as you move towards the right side, it gradually becomes more negative, and then beyond the radius it starts becoming less negative, and it is not linear. Then when you move towards the left side, it gradually starts getting more positive, and then once again it gradually decreases after the surface, and it is not linear. So then the correct answer is the third answer. In question number 32, two long conducting wires are vertically placed about 50 centimeters away from each other. In the diagram, spokes with a resistance of 0.5 ohms and fuse F are present, and a conducting rod is placed on the spokes, allowing it to move on the spokes. There is a magnetic flux density of 1.5 T across the system in the direction shown, and the resistances of the spokes and the conducting rod can be considered negligible. When the rod is released from rest, What is the mass m of the rod required for the fuse labeled as 4 amperes to be blown out when moving down the rod is vertical? So here, actually the calculations are quite simple. What you have to realize is what occurs here in the scenario. So what happens is, as the rod moves downwards, it cuts through the magnetic flux. And as it cuts through the magnetic flux, we know that there's an electromotive force generated and a current generated. So there's a magnetic force acting on the rod upwards. And since there's a force acting upwards, and since its weight is acting downwards, at one point, this rod reaches a point where it's moving at terminal velocity. So when it's moving at terminal velocity, its weight should be high enough so that the current of at least 4 amperes is generated. At least 4 amperes should be generated for the fuse to be blown out. So this is the minimum weight. We are calculating the minimum weight that this rod should have in order for the fuse to be blown out. So here the calculation is, you can use the equation F equal BIL, and the magnetic force will be equal to the weight of the rod. So since we are considering the minimum situation here, we can use the value 4 amperes for the current. The mass should be equal to at least 0.3 kilograms. So that means the mass should at least be equal to 300 grams. So this is the minimum mass that the rod should have. But the correct answer is, the mass should be greater than 300 grams. It should either be 300 or greater than 300 for this fuse to be blown out. So the most accurate answer is the third answer. Moving on to question number 33. A ball of mass m falls from a height h onto a wooden board fixed with a spring of spring constant k. When this ball falls on the wooden block, if the spring compresses by a displacement x, the correct expression for x is. So here it should actually be corrected. The correct expression for h is, they are asking the correct expression for h. So here what happens is, there's a wooden plank which is fixed onto a spring. This spring has a spring constant of k, and a ball is dropped from a height h. Now after the ball is dropped, after the ball lands on the wooden plank, the spring compresses by a distance x. So the total distance, the total height the ball has moved from its original position is h plus x. So we should always remember that the ball is moving a x distance as well, since the spring compresses. So we can apply the law of conservation of energy. The initial energy should be equal to, the change in potential energy should be equal to the elastic energy stored within the spring. So we can apply mgh plus x should be equal to half kx squared. So we are getting an expression for h, so we can substitute h. We can subject h. So then the correct answer is the fifth answer. In question number 34, a charged particle with a charge of q enters an area with an uniform magnetic field while traveling at an inclination of theta with the direction of the field at a velocity v and moves in a helical path. If the mass of the particle is m and the distance it travels during a periodic time parallel to the field is p. So we have to find the distance that it travels within the magnetic field during a periodic time. So let's consider that there is a magnetic field moving to the right side. Magnetic field to this direction, and then a particle with the velocity of v enters at the angle of theta to the magnetic field. Then its horizontal velocity is v cos theta. So then first of all, we know that so this particle actually undergoes a centripetal force and then it undergoes a helical motion. So the angular velocity of the particle can be calculated using qb over m. Then we know that t is equal to 2 pi over omega, which will be equal to 2 pi m over bq. Then the horizontal velocity is v cos theta. So to calculate the distance that it moves during a periodic time, we can multiply the periodic time by the velocity. So the distance that it moves, which is p, is equal to v cos theta multiplied by 2 pi m over bq. So then the correct answer is the third answer. A voltmeter with an internal resistance of 1800 ohms has been connected to find the potential difference across a 200 ohm resistance. This resistance of 200 ohms has been connected to a cell with an electromotive force of 50 volts. The internal resistance of this cell is 20 ohms. The percentage decrease in potential difference across the resistance due to the voltmeter being connected in parallel is. So then here, since the voltmeter doesn't have infinite resistance, a small amount of current moves through the voltmeter. Therefore, there's an error that occurs here. We have to calculate the error as a percentage. So first of all, so the resistor of the circuit has a resistance of 200 ohms and a voltmeter is connected parallelly. The voltmeter has an internal resistance of 1800 ohms. So then this cell also has an internal resistance. It is 20 ohms and the electromotive force of the cell is 50 volts. So first of all, we can calculate the potential difference that occurs here across through this resistor as a result of the voltmeter being connected. So first of all, we can calculate the equivalent resistance between the resistor and the voltmeter. So for this, since there are only two resistors, we can use the product over sum method. We can get the product divided by the sum. The sum of 1800 and 200 is 2000. Then the equivalent resistance will be 180 ohms. So then considering the internal resistance of the cell, we can calculate the total current that passes through the circuit by applying V equals IR for the whole circuit. So in the addition of 180 and 20 ohms is 200. Then the current that passes through the circuit is 0.25 ammeters, 0.25 amperes. Then we can calculate the potential difference that is present across this resistor. So for that we can apply V equals IR. We know the current is 0.25 and the equivalent resistance between these 2 points is 180, which is equal to 45 ohms. Sorry, this is equal to 45 volts. So then we can consider this circuit, we can consider the potential difference that occurs here if the voltmeter wasn't present. So let's draw the circuit again. So here the total resistance of this circuit is 220 ohms. We can apply V equals IR once again. I will be equal to 5 over 22. I'll leave this as a fraction. Then once again we can calculate the potential difference that is present across this resistor. This is equal to 45.45 volts. So here you can see that the actual voltage across this resistor is 45.45. But the reading that we get from the voltmeter, once the voltmeter is connected, is 45 volts. So there is an error of 0.45 volts. Then we can keep this error as a fraction of the actual value. Then multiply it by 100 to get the percentage. So this will be approximately equal to 1%. Then the correct answer is the first answer. Moving on to question number 36. A metal piece made up of a metal of density D has been placed within a block of ice consisting of a mass m and its temperature is minus theta degrees Celsius. When it is put into a beaker of liquid water at 0 degrees Celsius, it instantly sinks and hits the bottom of the beaker. If this ice block is to float in water, the mass range of the metal piece is correctly shown in. Within brackets they have given the density of ice. Here the density of ice, the symbol that is used for density of ice is sigma, which is not mentioned in the question. The density of ice is sigma and water is P. Specific heat capacity of ice is S and the latent heat of fusion of water is L. Assume that the final temperature throughout the system is constant and finally liquid water remains in the system. Ignore the heat capacity of the metal piece. So here final liquid water is also present in the system along with the ice block. So then all the water does not freeze. So what happens here? Initially, when this ice block with a metal piece is put inside the beaker, it immediately sinks. And since the ice is at a temperature of minus theta and the water is at a temperature of 0 degrees Celsius, The ice absorbs heat from the water, and the water around the ice block cools down and forms a new layer of ice around the block. And as ice forms, the volume of the ice block increases, and at one point the upthrust acting on it will be greater than the weight of the ice block and the metal piece. Then it will move up. So then the initial mass of the ice block is m. They have given the mass of the metal piece as simple m. We can consider the final mass of the ice block as ms. The metal piece is still present. So what happens is, we should first find out the mass of ice that is formed here. So then the heat energy that is absorbed by the ice block is the specific heat capacity of ice is S, should be 0 minus theta, which is actually equal to theta. So this is the heat absorbed by the ice block. Then the heat lost by the water is also equal to this, and so the new mass of water, that is converted to ice, we can consider it as simple m W. Simple m W is the new mass of water, mass of ice that is formed. So then this heat energy is used to form the ice. So mW will be equal to mWL. So then using this, so this m, the addition of capital M and mW will be equal to the final mass. Ms will be equal to, and the capital M plus mW plus, as well as the mass of the metal piece m. So then we can find out the increment of the volume here. So the initial volume of the ice block is we can multiply the mass by the density of ice, we have to divide the mass by the density of ice, which is sigma, and as well as we have to divide the mass of the metal piece by the density of the metal. This is the initial volume. So then the final volume is equal to this is the new mass of ice formed. Therefore, this is the new volume that is added onto the ice block. This is the final volume. Thereafter, so then the upthrust that is acting on the ice block will also be changed. So then upthrust will be equal to V rho G, as you know, and then the upthrust should be greater than the final mass of the ice block, than the final weight of the ice block. So we can use these two expressions and substitute in the values to find the final expression. Let's find the upthrust first. Upthrust will be equal to, then the total volume is this is the total volume. This should be multiplied by the density of water, which is rho and G. And we can get the common multiple. So instead of MW, we can substitute in these values. So MW is equal to MS theta over L. This is the final volume. So then the final mass is equal to, once again here we can use the ms theta over L instead of MW. So then the final mass is this is actually the final weight. The final weight is so using these equations we can equate the upthrust and the total weight of the ice block, and then the upthrust should actually be greater than the weight so that the ice block moves upward. There should be a resultant force upwards, and this is provided by the upthrust. So when you equate these two quantities, this is the total mass. And this is the upthrust. I have cut off the G on both the sides. Then we have to simplify these two equations and then subject simple m to get the final expression. So then once you simplify this expression, you will get the final expression as this is the final expression. So then the correct answer is the first answer. As shown in the figure, a quadrilateral made up of equilateral triangles, this should actually be a tetrahedron made up of equilateral triangles, has a plus q charge at its center. Figure B shows how one of its faces have been divided into more equilateral triangles. If the permittivity of the medium is epsilon naught and the electrical flux through A and B is theta 1 and theta 2, then which of the following relationships are correct? So then what they have given is a tetrahedron, and I'll take a side view of the tetrahedron like this. Then they have mentioned that the plus q charge is at its center. So then we have to consider the geometric center of the tetrahedron. So then the plus q charge is located slightly lower than the midway point. Then they say that each of the four sides of the tetrahedron is divided into four equilateral triangles. This is a side view of the tetrahedron. It is a 3D shape. Then each of the four sides are divided into another four triangles. Then there are 16 triangles overall. Then we know that the flux is equal to Q over epsilon naught. This is the total flux through the whole tetrahedron. Then we can take the flux through one triangle. Since there are 16 triangles overall, flux through one triangle should be equal to 16 epsilon naught. If the flux through all the triangles are equal, then the flux through one triangle is Q over 16 epsilon naught. But here, since the charge is located slightly lower in the tetrahedron, it is at this point. It is closer to the triangle B than to triangle A. Therefore, the flux through triangle B is greater than the flux through triangle A. The flux through triangle C and D are equal. Then the flux through triangle B is greater than, this should be simple Q, greater than Q over 16 epsilon naught, since there's a higher flux that's passing through triangle B. And the flux through triangle A is lower than Q over 16 epsilon naught. This is because the charge Q is located at the center of the tetrahedron and a bit towards the bottom of the tetrahedron. Therefore, it's closer to the triangle B than to triangle A. So then the correct answer is answer number 5. In question number 38, a type of glass used during manufacture of bulletproof vehicles is used to make sheet of glass of thickness D. When bullet passes through this glass sheet, its velocity decreases by 50%. In minimum, how many of the above mentioned glass sheets are needed to stop the bullet? Then the thickness of this glass, one sheet of glass, is D. So what happens is when the bullet passes, if we take the initial velocity of the bullet as v, once it passes through the glass sheet, its velocity is decreased by 50%. So then the final velocity is v over 2. So if we apply the linear motion equations, we can find the deceleration that occurs that occurs while the bullet passes through the glass sheet. So when I apply V squared equal U squared plus 2as. So then the final velocity is V over 2. Initial velocity is V plus 2. What we are trying to find is the deceleration. S is equal to D. So then A is equal to 3V squared over 8D. This is the deceleration. This is the deceleration. This is the deceleration that occurs when the bullet passes through a glass sheet. So we have to find out what's the thickness of the glass sheet that is required for this bullet to stop within the glass sheet. So in the second scenario, the initial velocity of the bullet is V, the final velocity is 0. We don't know what the thickness of the glass sheet should be. We'll take it as x. Then we can use the same equation once again. So then the final velocity is 0, initial velocity is v square plus 2. Instead of a, we can use this expression. S is equal to x. So v square is equal to 6 v square x over 8d. We can cut off v square, then 8d over 6 equals x. X is equal to, we can divide 8 by 6. We'll get 1.3 triggering D. So then the glass sheet should be greater than 1D and it can be less than 2D. So then the minimum glass sheets that are required for the bullet to stop is 2. We need 2 sheets of this glass for the bullet to be stopped. So then the correct answer is the first answer. In question number 39, as shown in the figure, a system of two thin, small and large concentric spheres connected to each other using a conductor has a total charge of 20 coulombs. If a charged particle of, this should actually be corrected, if a charged particle of 5 coulombs is kept at the center of this system, what is the magnitude and direction of the charge traveling through the conducting rod? The ratio of the radii of the small and large spheres is 1:2. So there are two spheres that are connected by a conducting rod, and the spheres have a total charge of 20 coulombs. So now the total charge of 20 coulombs is on the surface of the outer shell. The outer shell has a charge of 20 coulombs. So in once a plus 5 coulomb charge is placed inside the inner shell, what happens is there is an induced charge on the inner surface of the shell of minus 5 coulombs. As a result, there will be an induced positive charge on the other side, which will be equal to plus 5 coulombs. And due to this, there will be an induced charge on the inner side and then finally another induced charge on the outer side, which is equal to plus 5 coulombs. So due to that, the total charge on the surface of the outer sphere will be 25 coulombs. So for this to be 25 coulombs, a negative charge should flow from the outer shell to the inner shell, and as a result the outer shell becomes more positive. So then for the outer shell to be positive by plus 5 coulombs, a negative charge of minus 5 coulombs will be flowing from the outer shell to the inner shell, and as a result minus 5 coulombs will be flowing from the outer shell to the inner shell. So then the correct answer is the fourth answer, minus 5 coulombs from the larger sphere to the smaller sphere. In question number 40, the figure shows how a metal cylinder of radius r is present on the BC plane. AB and CD are light strings of length L from which BC is hung horizontally. The linear expansivities of the material of the string and the metal of the cylinder is alpha 1 and alpha 2 respectively. For the center of the gravity of the metallic cylinder to not change during a small temperature change, the value of alpha 1 or alpha 2 should be. They have said that the length of a string is 4 times the radius of a cylinder. Theta is equal to 30 degrees. For small changes in temperature, we can ignore the difference in theta. So what happens here is when there is a small temperature change, the radius of the cylinder will also increase. At the same time, the length of the strings will also increase, and as a result the BC plane, the BC horizontal plane will be slightly lowered. When the radius of the sphere increases, the cylinder, the center of gravity should remain the same. Then, if we take the initial radius as r, and then there will be a change in the radius of delta r. Let's take the change in the height of BC as x. So if we draw a perpendicular from this point to this point, the length of the string initially and the final length of the string, which I have indicated using a dotted line, up to this point is equal. So then this is the expansion of the string. This is the additional length that is created due to the small temperature change, which we can take as delta L. So and if this is theta, this is 90. So then the angle between x and the perpendicular drawn is also theta. Therefore, delta L is equal to x sine theta. Then x is equal to delta L over sine theta. Now we know that delta L is equal to alpha 1 L delta theta, and delta R is equal to alpha 2 R delta theta. Now we know that sine, here theta is 30 degrees. So then delta L is equal to x is equal to delta L divided by sine theta, sine 30 degrees. We know that sine 30 degrees is half, so then x is equal to 2 delta L. Then x and delta R should be equal for the center of mass of the cylinder to not change. Therefore, we can equate these two. So if x is equal to 2 delta L, Instead of x, we can write 2 alpha 1 L delta theta equals alpha 2 R delta theta. We can cut off the identical values. Then alpha 1 over alpha 2 is equal to R over 2L. Now they have said that L is equal to 4R. Therefore, alpha 1 over alpha 2 is equal to 1 over 8. Then the correct answer is the third answer. In question number 41, consider systems A and B shown below. There is an ice cube floating in A and there is another ice cube floating in B with a pebble within it. True about the water level of the above systems when ice cube melt in order is. In situation A, since there is only ice, when the ice cube melts, the volume is occupied by the water that is formed as the ice melts. So there is no change in the water level. In situation B, since there is a pebble inside the ice cube, as the ice melts, the total volume decreases, and as a result, the upthrust also decreases. And as the upthrust decreases, the water level decreases as well. So, the correct answer is the third answer. The water level doesn't change in A, and the water level decreases in B. In question number 42, two charged particles of mass m and charges plus q and minus q are positioned at the two ends of a stationary rod of mass m and length 2d, which is then placed in an uniform electric field with an electrical intensity of E. In a plane perpendicular to the plane of the electric field, when the rod is released with a small inclination, what is the periodic time of the simple harmonic motion it involves in? Moment of inertia around the center of the rod equals 1 over 12 ml square. So if we consider that there is a small inclination of theta on the rod, then there is a force of EQ acting on the electrical charges. So this is equal to 90 minus theta. Since this is equal to 90 minus theta, then the resultant here the vector after we resolve the force, R will be equal to F cos 90 minus theta, which is equal to EQ sin theta. Then the torque acting on the rod will be there will be a similar force acting here as well. Therefore, the torque will be 2 EQ sin theta d. Since the total length of the rod is 2d, the length from the center of mass to the edge is d. Thereafter, when we consider tau equals I alpha, we can get the moment of inertia as 1 over 12 m 2d square plus, we have to add the masses, the moment of inertia that occurs due to the point charges being present on the two ends. So then the moment of inertia due to the point charges is 2md square. Then we can substitute those values in this equation. Here this should be capital M. Now we know that A equals R alpha. So alpha is equal to A over R. Then instead of alpha we can write A over R. And then here, since they have mentioned that this is a small inclination, so then for small angles we can consider that sine theta is equal to theta rad, and we know that S equals R theta. Then instead of sine theta we can write S over R. So in here you can cut off the R on both sides. So we know the characteristic equation of simple harmonic motion is A equals minus omega squared x. So in here S is equal to x, so then we can substitute in x instead of s, and then we can get this equation to show that this is in simple harmonic motion. And thereafter we can find the periodic time, which is equal to 2 pi over omega. So we can see that this is parallel to A equal omega squared x. Then using this, we know that omega squared is equal to this expression, and then using this we can get an equation for the periodic time. Here there should be actually be d here for tau. So then d instead of x, and d here as well, and here. Therefore omega is equal to root 2 EQD. Then we can multiply both of these terms by 3, md squared plus 6m d squared. We can cut off one of the d letters here and then substitute that here. T equals 2 pi This is the final answer. So then the correct answer is the second answer. In question number 43, when a pin is placed very close to face AB of a glass prism and it is observed from the face BC, and when moving towards B at one point, the image of the pin disappears. At that moment, the angle between the incident and the reflected ray is 68 degrees. What is the refractive index of the material of the prism? So here in this prism there is a pin positioned right next to the face AB. So this is a pin, and the ray of light emitted by the pin will get reflected here and then the person will be observing through the face BC, and at one point the image of the pin will disappear, and that is the point at where the ray of light forms the angle equal to the critical angle. So then we can consider this is equal to the critical angle. They have said that the angle between the incident and the refracted rays are 68 degrees. So then we know that when total internal reflection occurs, the incident and the reflected angles are equal. So then the incident angle is 68 divided by 2, 34 degrees. Now when we apply Snell's law, considering that this is the critical angle, then we can consider that the refracted angle is 90 degrees. Therefore, we are trying to find the refractive index of the prism. Therefore, n will be equal to 1 over sine 34. So, in sine 34 degrees is nearly equal to 1, it is nearly equal to 0.56. Once you divide 1 by 0.56, it will be 1.78. So, the correct answer is the second answer, 1.788. In question number 44, as shown in the figure, identical cylinders and identical boards are kept on top of each other. If the ratio of the angular velocity of the cylinders at the top to the angular velocity of the cylinders at the bottom is 3, then calculate the ratio of the velocity of the top board to the velocity of the bottom board. Here no slipping occurs between any surfaces. So here, if we consider that this point is stationary, then the tangential velocity is equal to the linear velocity of the sphere. Therefore, if we consider that this is the linear velocity is, so here once if we consider that this point is stationary and this is moving towards this side with a velocity of v or vw, then there's a velocity, linear velocity towards this side v, which is vw. Since the velocity at the lowest point is 0, vw is equal to r omega. And at this point, this is here the velocity is velocity v of the plank is equal to the velocity at this point. So then v is equal to the addition of vw and r omega. Since vw is equal to r omega, v is equal to 2r omega. And once again here, there is a linear velocity of v y. If we consider the linear velocity of the sphere as vy, and then there is a tangential velocity of 3r omega, which will be equal to vy minus 3r omega will be equal to v. Is actually 3r omega minus vy equals to v. 3r omega minus vy, since we know that v is 2r omega, we can consider vy as r omega. And here, this is the addition of both 3r omega, and then we will consider this as v2, and this is v1. Then v2 is equal to the addition of 3r omega plus the r omega that occurs due to the tangential velocity, r omega. Then v2 is equal to 4r omega. Then if we take the ratio between v2 and v1, this will be 4r omega, v1 is 2r omega, and the ratio is 2. So the correct answer is the third answer. In 45, as shown in the figure, beaker of water kept on an inclined plane inclined at an angle of theta to the horizontal is moving with an acceleration across the inclined plane. What is the angle that the water surface makes with the horizontal plane? If we consider this angle as alpha, is the angle to the horizontal. This is the angle to the horizontal. Then if you consider water particle placed here, then take its forces, there is a normal reaction that is towards this side, which is perpendicular. Then its mass, weight will be straight downwards. If you take this as R, this as mg. So here this is 90 degrees, 90. This angle is equal to alpha. Therefore, if we apply, there is an acceleration as well. There is an acceleration to this side. Then the horizontal component of the acceleration is, if this angle is theta, this is A cos theta, and the vertical component is A sin theta. Thereafter, if we apply F equal ma to the vertical and horizontal directions, first we will apply it to the horizontal direction, then it's R sin alpha equals m A cos theta. Then to the vertical direction, it's R cos alpha minus mg equals m A sin theta. After that, once you subject R cos alpha, be m A sin theta plus mg. Then we can divide equation number 2 by equation number 1. This will be tan alpha, which we can get the inverse of, which will be tan inverse A cos theta A sin theta plus g. So, the correct answer is the third answer. In question number 46, when an astronomical telescope is at normal adjustment, it has an angular magnification of 5 and the distance between the objective lens and the eyepiece lens is 24 centimeters. Using both of these lenses for another telescope at abnormal adjustment, a short-sighted person uses the telescope. If the far point of this person is 1 meter, what is the angular magnification of the telescope at this instant? So here first we can get we know that the angular magnification of a telescope is the objective length, focal length of the objective divided by the focal length of the eyepiece, which is equal to 5 here. And also the length between the objective lens and the eyepiece lens is the addition of the focal length, which is equal to 24 centimeters. Then using these two equations, we can get the focal length of the objective as 20 centimeters. The focal length of the eyepiece lens as 4 centimeters. So here the person that uses the telescope at abnormal adjustment is short-sighted. So he is wearing specs as well. If the far point of this person is 1 meter, what is the angular magnification of the telescope at this instant? So in here since the man is wearing spectacles, the image is formed as 25 centimeters from the observer, which is the least distance of distinct vision. And then we have to see where the final image of the telescope is formed, so that the spectacle of the observer forms the final image at 25 centimeters. So for that we can apply the lens equation for the observer's eye, in this manner, then 1 over u is equal to 4 minus 1 over 100. 1 over u is equal to 3 over 100 and u is equal to 100 over 3. Thereafter, once we consider the two lenses, the final image is formed at 25 centimeters, while the final image of the telescope is formed at 100 over 3 centimeters, while the final image that the observer observes is at 25 centimeters. So thereafter, we can get the height of this. We have for us to get the angular magnification, we have to get the angles. I'll mark this as alpha 1 and this as alpha 2. So then the ratio of the two angles is equal to the angular magnification. So the angular magnification is equal to alpha 1 over alpha 2. If we consider the height of this image as h dash and this as h double dash, we can get a tan value for alpha 1 and alpha 2, which can be approximately equal to alpha, since these are very small angles. Therefore, we can, for alpha 1, we can say that it's equal to h dash over (100 over 3). Alpha 2 is equal to h double dash 25. Thereafter, once we get the ratios of alpha 1 and alpha 2, so to get the value of h1 or h dash or h double dash, we can use the linear magnification of the two lenses separately by applying lens equation for the two lenses, and then obtain an expression instead of h dash over h double dash. So for that, first we can apply 1 over v minus 1 over u. Here we can multiply the entire expression by v and then get 1 over. So we know that v over u is equal to the linear magnification. So once we divide 112 by 20, it will be 5.6. This is the answer. So the correct answer is the fifth one. In question number 47, for the diode shown in figure A, the IV characteristic is in figure B, and for the Zener diode, the IV characteristic is in figure C. The cell in figure A has electromotive force of 9 volts and its resistance can be ignored. Out of the currents I1, I2, I3 and I4, the maximum and minimum currents respectively are. So once we draw the circuit, we can see that this diode is forward biased. So there should be a voltage of 1 volts here according to the IV characteristic curve. There's a current of I1. Here the diode is reversed bias. So then there should be, since this has undergone a there should be a breakdown voltage of 3 volts across this diode and a current of I2. Once again, here there is a resistance of 2R and a Zener diode here, which has a breakdown voltage of 2 volts. So 2 volts is maintained across these 2 points. This is R and I4, I3. So now there should be a voltage of 9 volts between these 2 points in both of these loops because these are parallel to the cell. Therefore 9 volts minus 1 volt should be equal to I1 R. Therefore I1 is equal to 8 over R. When it comes to I2 is equal to I2 2R is equal to 9 minus 3. Then I2 is equal to 3 R, 3 over R. Then when it comes to I3, I'll consider I4 first. I4 should be equal to I4R should be equal to 2 volts since the Zener diode maintains this 2 voltage across these 2 points as well. Then I4 is equal to 2 over R. Then thereafter, when it comes to this point, I3 and I4, both of these currents pass through the resistor 2R. Then I3 plus I4 into 2R plus 2 volts is equal to 9. Therefore, 7, once it's divided by 2R, then we know that I4 is 2 over R, then I3 is equal to 7 over 2R minus 2 over R. Then I3 is equal to 3 over 2R. Then I3 will be equal to 1.5 over R. So here you can see that I3 is the minimum current that passes through out of all 4 currents and I1 is the maximum current. So then the correct answer is the third answer. In question number 48, after heating a black body to a temperature T, all the radiation emitted during 1 hour is absorbed and is transferred to a mass of water at room temperature 68 degrees Fahrenheit. Its temperature increases by 1.8 degrees Fahrenheit. If the same black body is heated to 3T and all the radiation emitted from it during 1 hour is absorbed and used to heat an identical water mass, what is the increase in temperature of this mass of water in Fahrenheit? So here initially a black body is at temperature T and the mass of water is at 68 degrees Fahrenheit. So at 68 degrees Fahrenheit we have to first convert it into Celsius. So once you convert it into Celsius, this is, we have to multiply it by 5 over 9. and then subtract 32. Then the temperature in degrees Celsius will be 20 degrees Celsius. Then they have mentioned that the increment is 1.8 degrees Fahrenheit. So then the increment in degrees Celsius is 1 degree Celsius. So if there is an increment of 1 degree Celsius when the temperature is T, we have remember that in Stefan's law, the energy emitted is directly proportional to the fourth power of temperature. Once the temperature is 3T, the energy emitted will be energy emitted will be 81 times the energy emitted previously. So for 1E, if the increment in temperature is 1 degree Celsius, then for 81E, the increment in temperature is 81 degrees Celsius. But when 81 is added to 20, the final temperature will be 101 degrees Celsius. But water evaporates as 101 degrees Celsius, so here a small amount of water evaporates, and the remaining temperature is 100 degrees Celsius. This is important. We have to consider that the temperature of the water as 100 degrees Celsius. So therefore, the increment of temperature in water is 80 degrees Celsius. The increment is 80 degrees Celsius. So then once you convert this into Fahrenheit, we have to convert this into Fahrenheit to find the increment in Fahrenheit. So therefore, we have to multiply this by 905. Since we are considering an increment, we don't add 32 once again. We don't add it. We just have to multiply it by 905. The answer is 144 degrees Fahrenheit. The correct answer is the third answer. In question number 49, what is the equivalent resistance between A and B in the system of resistors given below? So here we have to consider this system. So here what we can do is, since an equal amount of current passes through the entire circuit, what we can do is we can break the circuit here, then draw these wires separately as loops. Then starting from here, we can see that these two resistors are in series. Then the addition will be 2R. Then the resultant of these two resistors is, we know that when we get the product over sum method, it will be 2R over 3. So then the resultant of these two is 2R over 3. And once again, these three resistors are in parallel, then we can add 2R over 3 plus 2R. Then the addition will be 8R over 3. So instead of these three resistors, we can write 8R over 3. Then once again, here we can consider that these two are in parallel. and that this is 2R over 3, and then here these two are 2R. Then we can consider that this is 2R, and then these two are in parallel. So for that we can use 1 over R plus 1 over R dash, which is the equivalent resistance of these two resistors, equals 3 over 8R plus 1 over 2R. 1 over R dash is equal to 7 over 8R. R dash is equal to 8R over 7. So instead of these two loops, we can use 8R over 7. So once again these three are in series, then we can add 2R to get the equivalent of those three, which will be equal to 22R over 7. Then these two resistors are in parallel. Once again we can get the resultant of those two resistors. So the resultant of those two resistors will be equal to 22R over 40. So here we can see that that these two resistors, we can write this, we can draw this entire circuit like this. This is 22R over 40, and this is equal to 11R over 5. Thereafter, once we multiply this by, we know that R is equal to 5 over 11, so then we can multiply this by 5 over 11. You can clearly see that this is equal to 2 over 8. This is equal to 2 over 8. That means this is equal to 0.25 ohms. Here also we can see that R is equal to 5 over 11, so this is equal to 1 ohm. Then we can see that these two resistors and these two resistors form a Winston bridge here, and this 22R can be cancelled out since these are in the ratio 1:4. Then after that, since this is R, we can multiply this by 5 over 11, then the resistance is 5 ohms. This can also be multiplied by 5 over 11. 44 times 5 over 11 will be 20 ohms. Then these two pairs are in series. Then we can write this. We can draw this circuit as 5.25 ohms and 21 ohms. Then we can get the resistance of these two. Then the resistance will be 21 over 5. The correct answer is the second answer. In question number 50, a horizontal shot is used on a billiard ball kept on a rough billiard table and its initial velocity is v. At the instant when the slipping billiard ball starts rolling for the first time, what is the velocity of its center of mass? Moment of inertia of a solid sphere is given as 2 over 5 mr squared. So what they have said is, there's a billiard ball and initially it starts moving with a velocity v and it's moving on a rough horizontal surface. So at first there's friction acting on it. We can consider the weight as mg. So in friction we can consider it as F, which will be equal to mu k mg. So due to the friction there will be a torque that is generated. Torque will be equal to mu k mg. We can consider the radius of the ball as r. This will be the torque acting on it. Then due to the torque, there will be an angular acceleration. And at one point, the ball will start rolling due to this angular acceleration. So then the torque will be equal to mu k. They have given the moment of inertia as 2 over 5 mr squared. You find alpha. Thereafter, alpha will be equal to mu k. And when it starts rolling, it will obey the law where the linear velocity will be equal to r omega. So at this moment, so then up to the point where it starts rolling, we have to consider the deceleration that occurs as well. And then using that, we can find the velocity at the moment it starts to rotate. So then this is F equal, when we apply F equal ma, mu k g will be equal to the deceleration, and once you multiply it by the time, we will get the decrease in velocity. Therefore, v dash, which is the velocity at the time it starts to roll, will be equal to v minus mu k g t. This is the time taken for it to start rolling. And by the time it starts to roll, omega will be equal to alpha t, which will be equal to 5 . Then we can see that v dash will be equal to r omega dash. Therefore, so here, after that, v will be equal to mu k g plus 5k to r. Then t will be equal to Using this we can subject T, and then T will be equal to 2V over 7 mu K G. Thereafter we can substitute T here and then find the velocity at that moment. So V dash is equal to V minus 2V over 7. So V dash will be equal to 5V over 7. So the answer is the fourth answer. And with that, this discussion comes to an end. Thank you for joining our paper project, and we wish you all the best for your exams.